Okay, good morning. I'll be teaching today factors affecting separators, different separator section, different types of separators, and vessel internal. What are the different equipments or fittings are there inside separator? I'll just try to discuss in this lecture. This is basically for two phase, but the internal part will be in general for other separator also. And the topics are covered in the book Arnold and Stuart Morris, Surface Production Operation, Volume 1. I think this is chapter 4. Previous lecture we have seen two phase separator, horizontal separator. We have drawn like this. Inlet is there. There will be inlet diverter called inlet diverter. Right. Then there will be one layer of liquid oil plus water, and this is gas. And this is mist extractor, and if I have one valve, control valve, this is called pressure control valve, right? And there will be another valve here, this is level controller valve, okay, because if you are not maintaining level, then there will be problem. So you have to maintain level here. And in gas line, this is liquid. So in gas line you have to maintain pressure. Now this is the simplest form of a separator. Now actual separator will have several other fittings also. For example, there will be waves because the offshore systems are there. Then like fluid will be creating wave. So that wave will be creating problem. So we should have wave breaker. Sometimes we have vortex breaker and some other fittings we will discuss later. So this is two phase horizontal separator. Now similar way if I draw vertical separator, so again we will have inlet, okay, we will have again flow diverter, and we will have mist extractor. Side by side drawing so that you can understand what the difference. And if it is two phase, then you are creating like gas and oil plus water, and so you will have water out valve, water and oil mixture, liquid, okay, this is gas. In many cases there will be some downcomer. Downcomer means like vertical separator I have, okay, so I have vertical separator and one mechanism will be there like this. So although fluid is entering here, that fluid will be spread here only, okay. So there will be spreader and downcomer, later we will discuss in details. Now this is the simplest form of vertical separator. So similar way you have spherical separator, okay, inlet is here and you have flow diverter like this, you will have, so here design something unique, you see gas is going out, okay. So I am not drawing all the valves here, gas outlet valve, fluid is entering here and diverter, this one is diverter, okay, this is diverter, and this is mist extractor or demister or mist remover, mist extractor, okay. Different name will be there, so you should remember different names also. If someone is saying like mist remover also, that is fine. So fluid will be entering like this, okay, and liquid will be falling, it will create one layer, okay. So oil plus water or liquid, okay, or liquid, and gas will be entering through this mist extractor and you are taking gas out, okay. So this is specific design. So you should remember that different component, location and what is the function also you should remember, and we will discuss further different component, but then you will understand it is not so simple actually. Whatever you are looking at it, only a simple one vessel, pressure vessel is there and two layer you are creating, but it will be much more complex. When we will discuss, we will see, okay. Now we will see the whenever you are preparing, so please remember the difference between the separators, where which equipment is placed where, what is the purpose, okay. Factors affecting separator. So what are the different factors affecting? So separation efficiency will be higher or performance will be higher if you know what are the factors controlling the separation. Okay. So, one thing is the gas and flow rate, gas and liquid flow rate, gas and liquid flow rate. Liquid means oil plus water. Okay. So, that flow rate means you have to know minimum how much you are getting actually, how much maximum also you are getting, and how much average you are getting. But your system will be working on average side, but you should know minimum maximum limit also. If you do not know minimum limit, or if you do not know maximum limit, then sometime it will be crossing that some set of variables, setting variable, then whole system may not work. So, you have to know minimum and maximum flow rate, okay, and average also. So, what happens, sometime minimum will be very low and minimum peaks will be very lower, higher peaks will be very high. Okay. So, average will not be like average of minimum plus maximum, average will be like it will be time averaged. Okay. Time average means like first minute you will got this much flow rate, second minute you got this much, third minute you got this much, then you are making time average, time into flow rate, then you are making average. So, that is time average. So, that one actually will be actual average. Okay. If you are making like minimum plus maximum divided to 4, that may not work many times. Operation and design for different pressure and temperature. So, P and T. So, whenever you are designing or you are buying a separator, you should know pressure and temperature rating and how to operate it. Okay. So, that also will be affecting your separator performance. Surging or slugging tendency of the feed stream. So, feed stream, whatever fluid you are getting, so that is having surging capability, or it is giving lots of surge or slugging, then again your separation performance will change. Okay. Physical properties of fluid such as density and compressibility. So, if you know density and compressibility, then you know the separation performance. For example, you can remember the formula of settling. Okay, settling it was like D. Okay, then specific gravity was also there. Okay, those parameters were there. So, if you change those parameters, your separation performance will change. So, you have to know density and compressibility also. Okay, design degree separation. It's a 100% of particle greater than 10 microns you can remove. Okay, then degree is like 100%. Okay, higher degree your separation, but in some cases you may allow lower degree also, depends on different conditions. Okay. Presence of impurities. So, impurities means like sand is one impurity, H2S is one impurity, your paraffin, asphaltene, these are impurities. So, if these things are there other than oil and gas, then your separation performance will change, because sand may be blocking your flow path, paraffin will be choking all the items. Okay. Then accordingly you have to change your temperature, you have to change your pressure, you have to resize the whole system. Okay. Those are changing your separation performance, or you can say affecting separation performance. Corrosion tendency. Okay. Corrosion tendency, in that case actually if you have corrosive fluid, let's say H2S or sulfur dioxide, so in that case corrosion property will be higher. So, you have to check whether your material selected for separator system, that is not getting corroded or eroded. So, corrosion erosion will be occurring together actually. So, if you can avoid that one, if you know already beforehand, then actually you can handle properly. Okay. So, that these factors will be affecting your separation. So, the points are gas liquid flow rate you have to know, pressure temperature you have to know surging or sludging possibilities, physical property of fluid such as density, compressibility and viscosity, or these parameters should know. Okay. Design, then you have to check degree of separation, how much degree you want to get from your separator system. Presence of impurity, asphaltene or sand or other component are there. So, you have to check that one. So, that will be affecting your whole separation performance, because something will be clogging your small holes. Let us say mist extractor will be get clogged because of paraffin, or maybe sand will get deposited on the bottom, or maybe erosion rate will be higher. So, those things also important. And corrosive fluid also, if you have sand, again corrosive fluid is there, then erosion corrosion can occur together, that will be hampering your whole production system. Okay. Scrubber, two-phase separator to recover liquid carryover from the gas outlet to catch liquid by changing pressure or cooling. So, if gas line is getting lots of liquid, so in that case you can reduce temperature, so that some liquid will be getting cooled down, condensate will be created, so will be getting created, so your liquid will get separated. Okay, because gas line, natural gas whenever you are getting, actually it will be low short chain hydrocarbon or low molecular weight hydrocarbons, and your oil actually high molecular weight hydrocarbon. So if you cool down little bit, so high molecular weight hydrocarbon will be getting separated quickly. So cooling is one option in scrubber system, so that when you reduce temperature, your liquid particle with low higher molecular weight and low short chain hydrocarbons, those will be getting separated. Okay, and another way is that you change pressure also, you are changing pressure, so that time also some fluid, the high molecular weight fluid can get condensated. Okay, so condensation will be happening. So if you are not removing those things, actually your gas line will get blocked, the compressor will get having difficulty, and many other flow path will be getting blocked. Okay, so vertical scrubbers are commonly used in your oil gas systems. So vertical scrubbers commonly used. Okay, and major problem is that like blocking path and loss of economy maybe, right, because some oil gone through the liquid line, so that gas people, some low molecular weight oil that has gone into your gas line, so that may not be used by gas purchasing people, and you are also not getting money for that, so that will be loss of economy for that. So using water, actually you are removing dirt, maybe water you are removing, some oil also you are removing. Okay, so using scrubber you can remove the unnecessary component of gas from gas. 2-barrel separator, so many times you use 2-barrel separator instead of single barrel. Single barrel means like this is horizontal separator, this is vertical separator you have. So many cases you use 2-barrel separator will be looking like this. You can draw like this, then okay, and you have inlet here, inlet diverter is here, and mist extractor gas is here, and you are creating liquid layer here. Okay, so liquid out. Okay, so gravity settling section, gravity settling, and this is liquid collection section. Okay, this is liquid, maybe water and oil mixture. And why are you using this 2-barrel system instead of single barrel? If you are using single barrel, 1 barrel, 2 barrel you are putting separately, and you need more space actually. But if you are using 2 barrel, then 1 barrel gravity separating section, you are getting gas and liquid, and the bottom part actually you are getting calm environment, so that any emulsion or low density or emulsion particles are there, like say oil in water, water in oil, it will be separating quickly, or gas will be coming out quickly. So you are creating a calm environment, so that less turbulence will be created at the bottom cylinder or bottom barrel, and your separation rate will be higher. But these days, because of newer type separator system, single barrel, these are almost rarely used. Okay, because of additional cost and problem with single vessel is reduced. Additional cost is here, I mean this one will be having little bit costlier, and single barrel is having improved design now, so that's why people are not using this one. Okay, so this is called double barrel separator. What is the next one? Filter separation. So these are simple definitions. What are the things are there for different types of separation? Okay. So filter separation. If you have high gas and low liquid, low, high gas flow rate and low liquid flow rate, low liquid flow rate is there. In that case, you can use filter separator to remove liquid particle and other particle from gas. Okay, either horizontal it can be, or it can be vertical. So I have taken one picture from HCP Petroleum company. You can see these are the filters. Okay, these are filters, and fluid will be entering and it will be filtered out. Filtered out means solid and other particle will be caught in the filter, and regularly you have to remove the filter and you have to clean. Okay, you have to replace or you have to clean because dirt and other thing you are capturing inside filter. Okay. Okay. Next is cyclone separator. So one type separator is cyclone separator. I think you may be knowing cyclone, hydrocyclone, cyclone separator, or cyclone precipitator. So many terms are there. The cyclone separator is like this. If I'll draw one common type cyclone separator, then I'll explain. Okay. So cyclone separator will be like this, and fluid entry will be tangential. Okay, it will be like this. If I take top picture of this one, it will be looking like this. Okay, fluid is entering here, so tangential fluid entry is happening. Okay, so if I make okay, I'll try to make one separator system with my this one. I say this is cone type system. I hope it will be visible in camera. Okay, and they are tangentially fluid will be entering. Fluid will be entering tangentially. Okay, you are giving at the center, it will not work. It have to give tangential entry, so that when fluid is entering, it will be rotating. Okay, so it will be touching tangentially, it will be rotating with this inside. Okay, so this is called tangential entry. So here same thing happening, it will be rotating, fluid will be rotating like this. Okay, and if you see the bottom picture, here fluid is entering like this, it will be rotating and going down. Because of gravity it will be going down, and because of centrifugal action it will be rotating. Okay, so rotating and down, 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 down. So what is the benefit here in cyclone separator? Benefit is that if you have two different density fluid, let's say sand and liquid. So different density, high density, if you can remember this mv square formula, high mass it will create higher radius. Okay, lower mass it will create lower radius. Okay, so high density fluid will try to take larger radius, and low density fluid, let's say sand is there and oil is there. So sand is high density, so sand will try to touch this separator surface, sand cyclone separator surface, but oil also will try to touch, but oil will not get space. Sand will say, hey, my mass is higher, so I will touch this one, you cannot touch because of the density difference. Okay, but both the sand will be rotating and it will be going down. Then your low density particles, it will be collected at the center. Okay, so low density particle will be rotating at the center. Now you put on another pipe, you suck it. Okay, so low density particle will be rotating in the center, and low density particle is sucked from here. Suck low density particle, low density. Okay, and high density particle. High density means maybe sand, or you have oil water mixture also, you get very high centrifugal action. So in that case also high density means water may be falling down, oil low density will be moving up. Okay, so you can create separator also using this cyclone, and you can separate oil and gas. Okay, one is that wellbore fluid pressure is high, so use directly that one. If that pressure is not so high, then you can use some centrifugal pump, again you give high pressure and high velocity and it can be separated.